This conference will now be recorded.
Okay, so today I'm going to teach you the most important resources which you used almost 80 to 90% of the time while working with the Kubernetes, and those are like one is pod, before that namespace. Namespace yesterday also I discussed, right? So namespace, then pods, then we have a replication controller. Let me write in full because you guys are just first time probably hitting it. So replication controller, and then we have a deployment, and then we have a service. So these are the most important one. Now if you want to understand in a simple way, and if you know any of the clouds, a little bit of it, so then probably this pod you can consider as a compute unit. Pod is like a VM kind of compute unit. Here you have a virtual machines, here you have a pod which has a containers. Compute unit, that means anything you want to compute, you require a pod containers in Kubernetes. A replication controller, you can something like ASG, auto scaling group, where you have a multiple pods and then plus check. Okay, multiple pods and check. I'll explain it to you here. If you want to understand the deployment, so deployment is something like ASG, which has a multiple pods. You can get it and check also, but plus also you get a rollback option also, rollout option and rollback options also you get it. So this I will discuss with you while demo. Now services, if you want to understand in a simple way, then it's kind of load balancer for the pod. Okay, load balancers for the pod, but this services is like a network load balancer. Two types of load balancer we have, right? App load balancer and network load balancer. So this is a kind of network load balancer for the pod. So these are the most important services resources which you will use in a Kubernetes. Make sense, all of you?
Yes. Yeah.
So anything which you do, I have shown you yesterday so many resources, I think 64 resources. You'll have to do the CRUD. CRUD means create, read, update, delete any resources. Okay, yesterday I have shown you a little bit of glimpse of it. So create you can do through the command line also. Create command you can do through YAML file also. Okay, so CMD and YAML, both options you have it. So whichever way any resources you want to work with, you can do that. So kubectl is a common command if you remember, and accordingly you can do typically anything which you like to do with any resources. So the only thing is now you have to learn only all these resources, their properties, their feature, and when to use all kind of things, out of which some of these important one I'm teaching you. So read means get, and here get. Update means edit. Okay, and here apply. So edit means this is a command line, and if you have changed the file, YAML file, then you can apply this. So this will update this. Delete, command line, and other options are same. Why we use YAML file? Because over the command line it's very difficult to pass all the parameters. So typically we put it everything in the YAML file and deploy it. But sometime one or two activities you can do to the command line also. Okay, so now this is my clusters. Let me show you the namespace. CRUD the namespace. So here get ns. Right now you don't have it, so I'm creating create ns. Uh, uh, Create ns Rajesh. Okay, so this is the one got created. See here, you can do edit also, and typically right now you are just getting used to it. So play with the labels, team, DevOps. This is YAML file. You have to learn the specifications for YAML. So get ns, you will show labels. Now these, how do I remember? So you have to uh, get used to it. Slowly you will come to know. So here you have all this thing. You can use describe also. Describe command. Okay, describe. Sorry, spelling mistake. You can use describe also. Okay, so creating done, getting done means read, editing also done, and delete. So this now done. Okay, so it's very simple. So one resources I did, and same thing. I'm going to create it one more time because I need that namespace. Okay, so done. So I have got the qctl get ns. So ns. Now I need a one pod. So for that you have a YAML file I shared with you yesterday. But anytime if you want any sample code, so put it up. Let's say Kubernetes pod example. Anything you want a example, and then DevOps code. So like that you will get my content, easy to get started. So this I copied last session. So again same thing, qctl create -f pod.yaml. Okay, and here you see I did pod.yaml, and here message is saying this pod named with Rajesh is already exist. So how it is, where it is. So qctl get pods. Okay, see this is running yesterday only, since yesterday. So why? So pod name has to be unique, and that's the reason it is not able to create. But the problem is pod name has to be unique in the namespace. So the moment you run this command, it is hitting to the default namespace. Remember. So if you want to see that Rajesh namespace which I created just now, see nothing is there. So if you want to create that resources in the different namespace, you can specify in the YAML file itself or over the command line also, that's okay. And now it's got created. See. So a pod name is unique. The scope of the pod is namespace true. If you remember yesterday I showed you. So pods can be created in namespace. So now if I again try to create in the namespace same, it will not create because Rajesh is already there. You can change the name and recreate it. That's not a problem. Okay. So remember that I'm not specifying all the time -n, but if you want to create in a different namespace, either you specify the command line options or you put it that field inside the YAML file itself. Okay, but if you do not specify by default, you will use a default namespace. Is it clear, all of you?
Yes, yes. Yeah.
Okay, so now kubectl get pods. I'll be working with the default namespace from now. So I created it, get it. I'm going to edit it. By the way, you can edit YAML file also and apply. If you remember this pattern, you have to get it. But you can do through command line also. But right now I'm doing through the YAML file. So let me modify this pod.yaml. I'm playing with the labels all the time till you get comfortable. So team DevOps and done. So it's a YAML file I have to apply. So how do we apply? So I'll remove this now. Apply. Apply. Save. So there's a warning, you can ignore it, and then last line if you read it, it's configured. Okay, so I did this. I get the pods. Now if you want to see that, so labels, same command pattern will be for everything. Okay, so commands will not change. Describe also you can use, which I have shown you last time. Describe pod Rajesh. Okay, so this is the complete fields. You have it, and you must spend at least 10 minutes. Don't rush. Okay, because see, in Kubernetes is not about the commands. It's all about how many observation you'll make to the fields. And in Kubernetes you have a 66 resources, but you have a 6,000 fields, so you cannot memorize it. The only thing is you can learn the techniques to become comfortable and familiar with it. So if you get familiar with it, it'll be easy. You cannot memorize it. So most important one is like IP address, and it is running in this node and all. The moment you read it, you will get it most of it. And these are the logs. Okay, event we call it here for the kubectl, kubelet, sorry, which is the agent, right? Event logs. Okay, so these are the information. Right now it's a very small pod, but in real time, this content will be 4-5 page long, depends on the specification for the pod. Okay, so now this is done. You can also edit command line also using command line, edit command, same pattern, whatever I taught you last time, same pattern. And you can modify whatever the fields it can be, because some fields you cannot modify, some fields you can modify. Now this is a experience and learnings over the period of time you'll get it. And that's the reason I'm hitting only the labels to modify right now, because I know that that can be modified for all resources anytime. Okay, so now if you see that here I modified. Okay, so edit also you can do that, and finally once the requirement is done, you can delete that. Sorry, so you can delete to the command line also, but I'm deleting to the YAML, so that way whole pattern you will understand in one go. I run it and it deleted it actually, but some bad command also I run by with that, so you can ignore that. Okay, so it's gone. So this is the way you do the CRUD. So now same thing, what I did with the namespace and what I did with the pod. Are you comfortable? Yes, yes. Now next question is how to consume pod. That is a question. How to consume pod. So for that, I think you don't need to learn from me. If you remember the Docker, same command, something similar command will work for it. Let me show you the commands. So if you want to consume the pod, uh, here these commands will help you. Let me show you. Where is that? These commands. So if you remember the container, then it will help you. So this I have shown you already. Logs, attach, exec, port forwarding, proxy, not required right now, auth, not required, debugging also not required, and all. Do you remember these commands in the Docker? Okay, so same behaviors you have for the Kubernetes also. So let me show you. So I'm going to create a container. So kubectl apply pod. Directly you can do apply instead of create also, that is possible. Apply has a two. Why this is, when I press the tab it is creating a trouble, so I have to set the tab. I'll do that later. For time being I will type it. Okay, so now kubectl get pods. Now you have a pods. Now what is the IP address for this? So here wide you can describe and you can see that, but over the command line you can see that IP address, this one. So this pod is having containers, and the containers will be accessible through the insider clusters. You might have seen yesterday, right? See here. I'm inside a cluster. My workstation is in master. Please remember that. Just I wanted to access this one. That's the reason workstation I configured in the master. But typically, if your workstation is outside of the clusters, which then you will not be able to access this URL, because the scope of the pod is only inside a cluster. So I can access. But I want to see the logs of it. Okay, so how do I see that? So kubectl logs and then container name, pod name, and you see only one times I hit the curl, so one logs is there. If I hit the two times, you will see the two logs are there. So you can see the logs of the container of that particular pod. Attach will attach to the PID on of the container. It's the same behavior, just like you have done in the Docker. So let me show you. So you have a two logs, which is a HTTPD container. This is the Apache Nginx container, by the way. So you want to see that. So Docker attach Rajesh. Okay. Oh, sorry, my bad. kubectl attach Rajesh. kubectl attach Rajesh, and see that. Now, if I go and log in from the different locations, you are seeing the live log, okay? Ubuntu. And if I hit this one, see here, live log, you can see one more time. See. So attach means you attach to the Nginx console, and whatever the uses of the Nginx of that particular container, you can see that. Same way as we had in a Docker. Exec, you can execute any commands executables inside a container of that particular pod. Okay, same with a Docker. So how can you do that? So let me show you. So Docker, not Docker, I got a habit of it. kubectl exec -it Rajesh, and what you want to execute, bin bash. I don't know whether bin bash is there. I'm expecting maybe. Yeah, it's there. So where are you right now? You are inside a container, not in pod, right? Pod is a logical unit. Container is a physical unit. So here you are inside a container, and contain this is the container of Nginx. So do whatever you want. PS is not there. Okay, exit, come out of the container. So exit you can use for getting inside a container. You can run some commands also. For example, let's say you don't want to interact with the container of that particular pod. So here I am running commands ls opt, and see, nothing is there in opt, I guess. tmp. Okay, so this command they have deprecated. Okay, so the command, this is the one which I run, they have deprecated. So they are saying, hey, now you use this command, this format. So no problem. It's the same command, but hyphen hyphen they are asking to use, so they will know I'm running a commands. Here it is. So now etc. See here. So like that. So hyphen hyphen you have to add. Actually, I run this command after 1 year, I guess. So this is a things. Earlier it used to work like this, but this is the recent addition. Okay, got it, all of you?
Yeah.
Hello.
So if you try
Yes.
to access the API server from the outside, how will do that? I mean, do we require IP whitelisting? I mean,
No, that's where that this command will help you. Okay, same thing which we had in the Docker also, remember. So let me draw pictures, because if I explain it to you, probably you may not understand, because I never understood explanation. So this is your cluster, okay, and this cluster is powered by at least two worker, one worker and two worker. So this is one clusters, and your pod is running inside a cluster. That means it can be here or it can be here theoretically, but this pod is not accessible from outside. Because I was inside the cluster, theoretically I was in the master node, correct? Now this is a way, theoretically, I mean real, but theoretically you have to place yourself inside a cluster. This is your cluster, okay, powered by two nodes. So I was inside this, so I was able to access using curl command. But from outside, you will not be able to access, because this pod IP address, the scope is only towards a cluster. Make sense?
yeah.
So what do we do? So what we used to do in a Docker, we used to do the proxy, correct? That means we used to export the pod at the node port. Node port you can access? Yes, you can access. See here, clustered you cannot access. But node port you can access, right? I'm doing SSH using node port, node IP address only, right? Correct? No?
Yeah.
Node you can access it. So that is where you have to do the port forwarding. But again, this is at the low level. Low level means pod level. And there are so many techniques are there which you will come. I'll teach you. There's a service also which will save you lots of tasks. Where is service? Somewhere here. So I'll talk about it. Okay. So
Okay.
here this is the one. So what we do? So port forwarding. So let me do the port forwarding and let me access. So right now container is not accessible. Qctl get pods hyphen o y spelling mistake. Okay, so this is the IP address of the pod, cannot be accessible. You see, from anywhere outside of the cluster cannot be accessible. So what we do? Port forwarding. Port forwarding at what? At the node port. Any node port you can use it. So node port means node IP address and port number. Okay. So how do we do that? So the command is port forwarding here, this one. But how can we apply this one? So this command I completely forgot. But if I forgot, not to worry. You just write this one and then this one and then hyphen h. You will get an example. So you get a plenty of example and have a little patience. You have to do little bit of study. You have to spend multiple hours and all to practice it. I need this command actually. Okay, so this command will port forward, see, address from everywhere. Okay, from everywhere for this pod should be, and this is the node port, this is the container port. So container port is nginx 80, which I cannot change. This you can change based on the availability on the node. Okay, worker node or master node. So I'll leave it as it is because I don't care right now. So but this you have to be keep it the container port. So now this command will help me to run it. So let me run this here. What is this? Port name I changed not. So Rajesh. Done. So now it is forwarding. Now if you control X, it will call that, close that connection, port forwarding connection. So right now it is forwarding. That means if I hit the IP address of node and the port number, I will get the container. Let me show you. So I forgot the IP address of node and 888, right? And remember, I have enabled all the port number on a security group of AWS. So that's the reason everything is accessible. So please remember that when you try, probably I've seen like many guys got frustrated. They saying that Rajesh, whatever you have recorded, it's not accessible. Uh, and so simple thing. I open up my security firewall to the extreme wide, but most of the time people ignore that fact. Okay, so please remember that. Got it?
Yeah, got it.
So this is the one I am able to access. But actually, you know what? This is only for learning purpose. This all commands which I'm teaching you. You have a different and better way to do that. I'll explain it to you later. Okay. So there's a connections. If I hit one more time, one more connections, you see. So all this thing is coming. Okay. So port forwarding is also command very good. Now cp command can be used for copying the files to container of that pod or from the container to the host machine. So let's say this is the file. Okay, I want to copy in the Rajesh container. So the qctl cp command, spelling mistake I guess, cp command and this one, and then where Rajesh and where the location opt. So I copied. Now kubectl exec Rajesh ls/opt. and you see that pod.yaml is there. You can copy reverse back also. So here this is the source and this is the destination. You can make it this is this as a destination source and destination is a dot, means current location. So both the way you can do that. Events. So I kubectl events Rajesh, and these are the events which you have seen in the describe command. If you remember, same you will see at one place. Now this is for the looking at the logs of the container of that particular pod. Basically, let me tell you, this is a kubelet logs. I repeat, pod will not generate any logs. Please understand that pod cannot generate a logs. Why? Because pod is a logical unit. Who can generate a logs? Container, which is having application, or kubelet, which is application inside your each worker. So this one, when you say events, okay, basically it's a kubelet log. Whatever you do on the kubelet, you see that. So you see that started a container, created a container successfully, pull the images and all these things you see, these all are kubelet events. So this is the way to troubleshoot your behavior. But though once you get into the deployment and all, hardly you get a time to see that. But sometime when you are in a troubleshooting, observability and all, it will help you. This all skill set will help you. But again, depends. Okay, so here you see that all these commands are helpful for you to interact with the pods and containers and so on. Are you okay, all of you?
Yeah, Rajesh.
Yes. Yes. Yeah.
So next one is replication controller. So what is a replication controller? Don't get complicated too much. Using pod, kind is equal to pod, you can create a one VM. I mean, sorry, one pod. Mind it, one pod. That's all. You saw that I created only one pod. But how can you create multiple? So there is no for loop or something like that in YAML. You cannot do that. It's a declarative language. So what Kubernetes has given it to you, they have given it to you replication control, another resources which basically can create a multiple pod. Basically internally they will call this one only, but multiple times. But a replication controller has a two feature. Let me put it up in a simple way. One feature is it can replicate to multiple pod. Okay, multiple pods. Second thing, whatever the pod you it can replicate, whatever, let's say I say 5 pods I will replicate. So it will, Kubernetes will make sure always 5 pods. This is the job of the controller. If you remember controller manager, so you said, hey, I want 5 pod, so you'll always be a 5 pod. Let's say if it will become a 4 pod, Kubernetes will create one more pod. That means replication controller has two features. One is replicate as many pods you wanted, that's what desire, and then Kubernetes will maintain that desire. Let me show you. So here I will go for the resources rc.yaml. So means, so here Kubernetes and go for RC or application controller, whatever you can put it up. This is the one. Okay, so you have some code here. I will take it up, this code. Now this code virc.yaml command will remain same. Remember that there's no much difference in pattern. See here, what you want, replication controller. What is the name of it? So the name I want little bit simple. So I'm going for Rajesh only. Pod name, RC name, both are different objects, so you can keep it. How many pods you want? Replicas 3. Of which, so in that each of these replicas, which containers will be filled. So this is my image which I created for the demos and so on. So three containers will be created. 3 pods will be created. So same way, CRUD you have to do. I am not going to repeat the same thing because it's the same pattern. rc.yaml. And now you see that kubectl get pods. You see that 3 pod got created. So now you can play with the pods commands which I have already teach you, but you can do rc also, get rc. Now you can edit RC also. So now I'm doing through command line RC Rajesh. So how many pods you want? So I'm going to change the replicas now 3 to 5, and you see, save it, and you see suddenly you got a 5 pods actually. See, 5 pods. Okay, one I created using pod specification, and remaining 5 I created using RC specification. So you can do edit. So you can create, get, okay, and read, and then finally you can delete also. Delete RC, name of the RC Rajesh. All pod got deleted. See, gone. But again I have to create it one more time. Let me create it. I created again 3 pods to get it because RC was having 3, and so now this is the one. Now so this feature which I showed you, you can get as many pods you wanted using a replication controller. But another one which I said, let's say you set a desired 3 or 5, whatever it is. So that's a job of the Kubernetes to maintain that desire. So let me show you the magic here. So here kubectl get pods, and these pods you have a 3 pods right now. So these 3 pods right now is running in your cluster irrespective of which node and all. Okay, but due to some reason, let's say one node is down, you have to create a hypothesis. But right now I cannot bring the node down because I have only one node. But real time it can be multiple nodes. But I am deleting manually. There is a one pod. Okay, look at the age 32, 32, 32. So I'm deleting one pod manually to create this accident. Okay, so see here, I deleted, and now you see the magic. See that? So whatever you set the replication controller is a job of the Kubernetes to maintain that desire, and they will keep fixing it based on the whatever you set in the replicas. Make sense?
Yeah, got it.
Okay, so that is a replication controller. But let me tell you one bad news. Replication controller also got deprecated. It's not removed. That's the reason it was working, but deprecated. So what you got it? So you got a next resources, which is called deployment. Okay. So this has a multiple feature. So let me tell you, this have a one feature, a replication, one feature which is called replication, which you can replicate as many pods, and this has a controller feature also. Controller means whatever the desire you did, that will be maintained. But you know what, these two feature which they have it, so they have it, but you know, deployment internally uses replication control. No, they can use it, but they have not used it. Why? So what has happened? Replication controller has some bugs. Some bugs. So what they did, Kubernetes, they rewrite one new resources and they call it replica sets. This one. So whatever the bugs we had, it's the same feature. There's no change in the feature, but few bugs fixes. So whatever the whatever the bugs we had, they fix it and they release the one new resources. They called it replica set. So replica set and replication controller is the same. Most of the functionality will be same, but because it's the latest one, and instead of a replication controller, you can do RS also, replica sets. It will be working, but deployment is using replica set for this feature. Are you understanding?
Yes.
So yeah, remember that. So RC and RS both are same command line, same behavior, but deployment has a two feature, replication and controller, and they internally use the replica set. But the question is, what other features we have a deployment? So we have a three more features which has with the deployment: versioning, That means automatically whatever you deploy, automatically inbuilt it has a versioning 1, 2, 3, 4. What you deploy, which image you deploy in one deployment, which image you deploy in second deployment. So automatically all this meta information they store, and they have a rollout and rollback capability also. This is something which is a very good feature in the deployment. So these all 5 features is coming under the deployment. And let me tell you, deployment is one of the resources which you use till today. Most of the, means I would say 90% of the time when you want to deploy the pod, you use deployment. Make sense?
Yes, yes. There is
Okay.
one more
Yes.
like a stateful
Huh?
set. What is that?
So here deployment is used for stateless pod. A stateless pod means which is not having any data need to be stored. For example, database and all, you cannot deploy using deployment. But if you want to deploy uh, the pod which has some data need to be stored, then in that case, stateful sets need to be used. So stateful sets, basically you have a pod and which attached to the volume, data volume, and this has some properties which maintain the integrity of the data, which it has no feature in that. It got it this way. Okay, so this is the stateless, this is the stateful pods. Okay, so now let me show you the deployment. So same way, go to this, and here I'm directly moving to the commands which will help you to do that. Okay, this you can use as a command. These all are commands, are you understand, nothing new, but the only thing is I have it for easy run. Okay, so now first thing I'm going to show you, the how do we deploy using command line. You can do through YAML also, that's not a problem. So let me show you this command. Okay, before that, let me do the cleanup so that way it will be having complete good demo. So delete pod Rajesh and delete RC Rajesh also. Done. So right now I don't have any pods, any RC, everything is clean. Okay, so now I'm going to deploy. Now through the command line I'm doing. So here create a deployment, name of the deployment from this image, same image I've been using, and how many pods you want, replicas 15. That means 15 pod. Enter. And you got 15 pods altogether. Okay, it's creating, and it will create in the one node 8 GB RAM I'm using, so that way it will create in few seconds. Okay, so now you see that it is almost running most of it. Now you want, I said 3 features are there, right? Versioning, rollout, rollback. So I'm teaching you versioning. So for that, this command will help you to check the how many versions already has been done. I have deployed only one time, so only one version revision, you see, only one. So now you have a you have a record where you see that whatever you deploy, they automatically revision. Now you can also check that pod and what you have it. So you see that these are the uh, pods and kubectl, http IP address of one of the pod, and here you have a welcome to DevOps School v1. This is version 1 I deployed. Now I am going to deploy version 2. How can we deploy? So for that, I am going to deploy version 2, and for that I'm going to edit that deployment. This command, enter, and then change the image. Only image also you can change. See here, image v1 to v2. Just for the demo, I created these all images. So v2. And now quickly you run this command to check the rollout. See here. These are the history to revision, and check the history immediately. See, slowly it's changing all the content pods. See that? It's just a 15, so it will be faster. See, they have updated and then terminated the old replicas. And done. Now, if you see that, curl http, see the pods, see, upgrade has happened. So now, welcome to devopsschool.com/v2 space v2. So version 2. I deployed version 2. Now, if you see the history, see that history 1 and 2. So that means here image version 1 got deployed, here image version 2 got deployed. Okay, so now this is called, and you know what, this old rollout 15 pods I had it, I did the rollout, this all has happened with 0 downtime. Now the question is how it is possible. How, when you upgrade or roll back, anything you do, it is happening with 0 downtime. How? So for that you have to learn one techniques which is a part of the deployment, and that you will see deployment strategy. You see it here, describe deploy. See here, you go and read this one, and here you have to read this one. Strategy type, it says rolling update, and rolling update strategy 25% max unavailable, 25% max search. What does that mean? That means while roll out and roll back, make it create a 25% of the pod and then delete 25% of the pod. This is the logic. But the question is, what is a rolling update and what are the other strategy type we have it? For that you have to come to top of this screen. So here, understand that in Kubernetes deployment you have a 2 deployment strategy type of deployment. 2, recreate and rolling update. So rolling update was the default. Okay, so what is a recreate and what is a rolling update? You have to understand this. So in a recreate, what happens when you say I want to roll out or roll back? So in that case, what initially we had a 3 pods. Understand this image. Initially you had a 3. Okay, this is a not this is a right image. So initially we had a 3 pod. Okay, so in the recreate options, when you do, it will destroy all 3 and then recreate a 1.2 in one go. So that means here in this way you have a downtime for few seconds maybe, but you will have a downtime. Are you understanding?
Yes.
Okay, but if you go for the another one, which is called this one, uh, uh, rolling update. So this image is a rolling update. You see here, earlier we had a 3 pods, 1.1, and then they destroy 1, added 1, 2, 2, 3, 3. So that way you have a gradual update and without a downtime. So that's a default. Rolling update
It's a
is a
rolling restart,
default.
right? It's a rolling restart of the pod.
So this started with 1. So whatever you set here, whatever the logic you set here, it will be followed. If you say 1 max unavailable, 1 max search, it will be done. But here it's a percentage. So it depends. Whatever you set here, it will be done in the same fashion. Got it?
Got it.
So these are the 2 strategy. It will be most likely you ask in the interviews also. So please remember that. Okay, so now I have deployed to the version 2 of the pod, and which I showed you. Welcome to things. Now I want to roll back to version 1, which is this one. How do I roll back? So that is where you have a commands, this command. undo, rollout undo to revision number 1. And here clear the screen and done. It got rollback. You want to see the status. Fast. Yeah, here it is rolling back one by one, updating and creating a new one and destroying the older one. And done. Now if you want to see the pods and hit the pods, any of these pod to check that whether rollback has happened or not. So curl http and you see welcome to devopsschool.com/version1. That means rollback has happened. Correct. So these are the features which you have with the deployment: inbuilt versioning capability, rollout without a downtime, rollback without a downtime, and any given point of the time you can do that. So these are the 5 properties which you have with the deployment things. Apart from that deployment, we have a few more resources which can be used to deploy the pod. For example, stateful set for the stateful pods, and there's one more which is called daemon sets. You can deploy the pods. Here you have one more which is the job resources to deploy the pod. There's one more which you have a cron job to deploy the pod. So these are the few other options are available which you can deploy the pods, but you know each of these has a certain distinct qualities, and you need to study a little bit in more wide way. I mean, these all are simple, not a great thing, but these are the ways to deploy the pod but do certain activities also. For example, job will do run once the pod and then gone, but here it will keep running at interval, at certain interval, one pod or multiple pod, it will keep running at certain interval. This is a daemon set, one pod each node. I remember each node or each worker, it will create it. Stateful set, it will create a pod, multiple pod, but let's say one pod, two pod, three pod, but it remembers the volumes it got attached. So it always remember the volumes. So volume 1, volume 2, volume 3, like this. So pod number 1 attached to the volume 1, it always remembers. So now next time when this pod is gone and replacement will come, so always this pod will be attached to this one, and then this pod will be attached. So this is the memories actually, and many other features also we have it apart from this. So just I'm covering at a high level. Okay, so these are the resources. Which are the resources we learned? So one resources, two,
Rajesh, one
three.
question. Daemon sets when we use, I mean, and for what purpose?
Daemon set mostly used by the administrator of the cluster to get some information from the clusters. For example, you want to deploy the log extracting agent or APM agent or something like that. So daemon set,
Mhm.
in fact, you have right now also. Let me show you. But it's not deployed by us. It's deployed by Kubernetes. Let me show you. So
Okay.
kubectl get pods hyphen all namespaces. How many nodes we have in this cluster?
5, right?
No. Two nodes, no? One master
No,
and one worker.
oh, correct.
Yeah. So how many proxies should be there? Two. Each name spaces. See here. Two proxies there. Each of this node has one proxy, and this
Correct.
networking panel, right? So like that. You can see the hyphen wide also. See here. Node. So yeah, DS you have get DS. If want one pod, maximum one pod each worker, you can deploy. So here what Kubernetes has done, because networking you need in the every worker, so they deploy the kernel and proxy in each worker like that. Okay, so now we have covered almost, let me count it. So namespace 1, 2, 3, 4, and replica set 5. Okay. And then some of the discussion we did 6, 7, 8, 9, and 10. So overall 10. Now the most important resources what you have is services. What is services? So I just said services is for load balancing pods, but we need to understand the context. Okay. So let me put it in a simple way. Okay. So right now this is your cluster, and here in the cluster you have a 2 worker for that discussion sake. Now remember that there is a one pod which is a front end. There is another pod which is a back end. So remember that backend pod will talk, sorry, front end will talk to the backend, but backend pod will be accessible from outside. Correct now? Hello.
Yes.
Okay, let me draw a new picture. This is you. You will hit the front end pod like web server or something like that. Correct. And then this is the backend pod, application or maybe database or something. I'm just simple way I'm explaining it. Okay. So now the question is, you will hit which pod? You don't know. That is where we need a load balancer, right? So in the VM world, we need a load balancer, LB. So you will hit the LB through the DNS, and LB will either hit here or here or here or here. Correct now? And here, now the front end pod will hit which pod? Not sure. That's where we need one more LB, internal LB. And now this all connect to this load balancer. And then this load balancer will connect to one of which. Agree with me or not, right?
Yes. So there is two LB using for front end and back end, is it?
Yeah. So, but this LB will be internal LB. This has
Mhm.
to be external LB right now.
Got it.
That means this LB will be accessible within the network, which is a clustered in our case, or this LB, the one which you have, it has to be outside. Correct now?
Yeah.
So like that. So this same thing which I was drawing here, you have a front end pod and back end pod. So front end pod, you required one load balancer. Okay, let me change the color. Front end pod, you required a one load balancer. Backend pod also you require one load balancer. Change the color. Load balancer. Now the question is, this load balancer will be accessible only inside a cluster. Remember, this load balancing the pod. Pod is in which network? Cluster network. Pod is accessible outside of the cluster? No. So load balancer also will not be accessible outside the cluster by default. So now the question is, how do we create a load balancer? So for that, we have a services resources. How can we do that? So let me simply teach you. So you can write a YAML file, you can write all this thing, but simply I will use kubectl get deploy. I want to create a load balancer for each this all pods. So what to do? There's a many ways to do that. Okay, by the way, but one of the easiest way is expose -h. I forgot the command, so I'm trying to get it. And here it is. I'll create it. It's not a perfect code. So expose what? RS? No. Deployment. What is a deployment name? So it was a my dep, I guess. Just a second, hold on. So deploy. I want to deploy, and here. Now understand that target port is your container port. So my container is running on 80. Now this is your the new load balancer port. You can keep it 80 or 888. This one you can keep it whatever you want it. So target port is my container port. So this one, Let me run this command. So before that, kubectl get svc. Svc means service. So this is the default service which is for the API server, which is default. I'm creating another one. You see here, I'm creating one more service. Service is equal to load balancing, and this load balancing will load balances how many pods? Let me show you. Get my dev, get deploy 15 pods. Correct now? How do I know that? So describe all these commands. You know that by now. Same command which I have used, same pattern you have to use. So describe SBC and then this one. See here. Here you have endpoints, 15 pods. See, 4 here, I think 3 or 4, whatever it is, and 12 more. So they have these many pods. It's load balancing. That means if you hit here on 80 port, HTTP dub dub dub, one of the pods you will get it. Which one? Because all are same. So one of the pod you got traffic. Understood now? So this is the service IP address, load balancer IP address. Understood?
Yes.
Okay, but there is a problem. The problem is I got the service created, I got the load balancer created for the pods, but a scope is internal only. What do we do? What do we do? Because this load balancer, which is a front end, need to be accessible from this guy, which is not in this case. So what do we do? Same thing we will do what you've been doing. You will expose, please understand that. You will expose this particular front end service. I repeat, front end service to node port. Why node port? Because node port is accessible. Correct now? Node IP address is accessible if you open up a security group. So now the question is, how can we create a load balancer and expose that load balancer service to the node port? And for that matter, you have to use the type is equal to node port. So this will do the two things. It will create a service, and that service it will expose at the node port. How? Let me show you. So you have to change the name also, right? Name n node port np. I'm naming it np. Okay. So same command, node port. So clear the screen, enter, and you see here. Look at the difference now. See here. There is one which I created last time, which was the scope was clustered IP. That means scope is only within the cluster. But this service which I created, the scope is within a cluster plus outside also. So here the cluster service IP address, and at the node port, this got exposed at 31211. So let me show you node port. Where is that? 31211. See here, accessible, correct, at the node port. But there is one more problem. There is one more problem in this. This guy, have you ever hit the IP address of the node? No, we never hit the IP address. We always, if you look at this here, we always hit the load balancer, correct now? We don't hit the IP address of the node. So what do we do in this case? That is where Kubernetes will not help you. AWS and Azure will help you. Why? Because there is one load balancer need to be created outside of the cluster, which AWS will do, and this load balancer need to load balance this worker and this worker. I repeat, not a pod, worker. Why? Because this who's managing the VM? AWS. So load balancer will be created by AWS, and then people will hit to the load balancer of AWS. AWS load balancer redirect the traffic to the node, which is a VM, and from the VM already you know that where it will go. Are you understanding?
Yes, yes.
So how do we do that?
So in,
All these three things. So load balancer. This is the command to create a things. But this command will not work because mine is not EKS. It will, if it is EKS, then it will be done. I set up a manually. So see kubectl get svc. See here, I got the load service created LB service IP address. It will work. Node port also it will work. But this external the load balancer is pending. Why? Because it's not connected to the EKS. Let me show you. Curl http. This is working. See, this is also will work. See, and but load balancer which is here, which I am showing here, is not got created. But that command is right, but will not be created because not connected to EKS. So here. So now let me put it in a very simple way. Very simple way. If you need a service, please understand when I say if you need a service, the scope of the service should be accessible only inside a clustered, then that's a default clustered IP. If you need a service which you want to expose at the IP address of worker, then go type is equal to node port. And if you need a service which is accessible from outside of the cluster, then go for load balancer. Simple. Three types. There's one more type, but I'm not complicating right now. Make sense?
yes. So there was one load balancer for front end, and we are also providing LB from that cloud provider, right? So how it will be managed? I mean,
This is equal to cloud provider only. If you want to create a load balancer inside a cluster, this is sufficient
oh, okay.
service. Okay, this is for the this type is from the outside only. This one, which got into the pending stage, if you remember. Why? Because it's not EKS. It's a
Mm,
manually configured.
okay.
Okay, so these are the resources which you have to practice it and get going. There are many other resources we have already also. For example, there's a for secrets. Let's say you want to store something in the cluster. Something means some password, key, certificate, and all. So typically we use ConfigMap. There's another resources and secret. These are the two resources we use for uh, storing some information in the cluster itself in the etcd. Now if you're working with the volumes and stuff like that, then we have a few resources like a pvcs and a storage class. Three resources we have for the volumes work. Volume means ebs or something like that. If you want to attach some node which have a some pod which has a persistent volume, for that you have this one. Apart from that, for security, rollback, role-based access control, RBAC, we have a few resources which you have a roles, cluster roles. We have roles binding. We have a cluster role binding. So these are the one we have it. If you want to create another user, service-based account, so service account user and all. So I think these are the only resources which you use in a 99% of the time for creating a user service account, for authentication and authorization. These are the four resources. For volumes, three resources. For storing something in the cluster itself, like a password or keys or something like that, config map. And apart from that, we talked about this one.
Secret in
Got it?
grace, right? There is one called in grace. So
Ingress is not a inbuilt resources. In a way, let me tell you, Ingress you require an external tooling system. So let me put it in this way. You want load balancing. of the pods. Okay, so for example, if you want a network load balancing, then you need a service, which I explained it to you. But if you want application load balancing, then you need ingress. And for ingress, you need some controller. Okay, controller we call it, ingress controller we call it, and that is external actually. So you have to install some external tools. Lots of options we have it. So let me show you. Depends on the platform what you're using. So list of ingress controller DevOps school. So lots of options we have it, but depends on your platform what you're using. So see here, this is a very popular nginx. Traffic is also popular, ha proxy, istio ingress gateway also. Few more options you have it here like ambassador, and depends on the cloud. Every cloud have their own ingress controller, aws, azure, and so on. Got it?
Yeah. Got it. One more question related to pod. Okay, so in pod we have ML file we have like a anti-affinity rules, right? Uh,
Ha.
yeah, I mean the pod affinity. So what it does, I mean, generally distribute the pod across all the node.
No, no, no. So what happens? Let me explain it to you. Likewise, we have a more than 20 fields actually, not only anti-affinity, but many things you need to spend, and that is called pod observability. That overall the topic which is called pod observability. Okay, and this is the important work for the programmer developer who's developing the pod developer. Okay, developer. So many things are there, but as you ask anti-affinity and affinity, let me show you. So here, this is the cluster. Okay, and in the cluster, typically you have a so many worker will have it, and each workers you may have a different specifications. Depends on your project. This may have a 4 GB RAM, this may be Ubuntu, this is RHEL, this is Windows, and depends on the specification. Now, what you say, hey, my pod by default, if you say do not specify the affinity and anti-affinity, then it will go and randomly deploy anything. So it may fail also. But if you say no, 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 my pod should go and attach to only this node. So that way you said, hey, node affinity is this one. Anti-affinity means it can go for anything like that. Pod affinity means you are attaching the node. So if you have
Oh,
a some questions like this, let me show you. You just write whatever you have a questions, pod affinity Kubernetes and Kubernetes, and then end of it put the DevOps code. Okay, and then this you will understand, uh, and I have explained it this one. See, node selector, affinity, pod affinity, tents, and toleration. 5 concepts you have, and this way it will help you. So see that here, you are specifying pod selector, node selector. Here it's assigned to the node. So like that we have so many things actually, and you need
okay.
to go through that once you get into the development and all.
Got it.
Okay. Okay, so just practice it. I'll share this recordings after a couple of hours and then practice it. This is the most important tool. Kubernetes is the most important tool. You have to spend time with it. In LMS, by the way, in if you go to the LMS, you have a 20 to 25 hours of recording also. Okay, so right now 3 classes we have on the Kubernetes, but if you go for Kubernetes here, you have a 25 hours of recording also. So every topics, if you want in detail to be studied, you will get in this course. Okay, but yeah, your class recordings will be also available anyways. Okay, see you.